All right, let's talk for a second about momentum. Momentum, if we're looking for a definition for it, is really a pretty simple idea when it is what it is. Momentum is a measure of how difficult it is to stop a moving object. So try and imagine, for example, a tennis ball thrown at you at 10 miles per hour. Not a very difficult thing to stop. You could just catch it with your hands. It would be very simple. Somebody throws a bowling ball at you at 10 miles per hour. That's going to be not as simple to stop. You probably don't want to catch that one. Just get out of the way. So momentum is a measure of how difficult it is to stop a moving object. The more momentum you have, the harder it is to stop the motion. So things like, let's imagine a car traveling down the highway at 50, 60 miles per hour is going to have a huge amount of momentum. It's very, very hard to stop. Small objects, however, not so much unless they're traveling really, really fast. So think like a bullet is a very, very small object, but it's traveling very, very fast and therefore has a relatively high momentum. We can calculate momentum, and it's actually one of the easiest calculations we'll do in this class. Momentum is simply mass times velocity, and that's it. And we abbreviate this P. That's weird. No way around it. That's weird. P is our abbreviation for momentum. P equals mv. So m is our abbreviation for mass, v for velocity, just like we'd expect. But again, the abbreviation for momentum is P, interestingly enough. So let's look at an example of calculating this. Find the momentum of a 50-kilogram soccer player running at a speed of 3 meters per second. So what we're going to do is we're going to do this just like we've done all the others. First, what are we given? Well, we're told the soccer player has a mass of 50 kilograms. Notice that I'm specifying that 50 kilograms is a mass. Also, the speed is 3 meters per second, or the velocity if you want to be more precise. And what we want is momentum. So again, I'm just abbreviating that with a P. Next, we write down our equation. Momentum is just mass times velocity. So in this case, that's 50, our mass, plugged in for m, and 3, our speed, plugged in for v. And when we multiply those two together, we're going to get 150. But now we need units for momentum, and this is where it gets just a little bit ugly. The units for momentum are kilogram meters per second. Now that's worth taking another look at. I'm going to switch to a white background here so you can sort of see this. If you're writing this by hand, this is how you want to write that. Kilogram meter per second. And this actually makes sense. If we go back and we look at our equation, it's mass times velocity. The units of mass are kilograms. The units of velocity are meters per second, and we're multiplying them. So it's just a kilogram times a meter per second, and it looks like this. And with other things, I'm thinking of the Newton in particular. The unit is the Newton rather, is a kilogram meter per second squared, but we shorten that. We give it its own name. So rather than write out kilogram meters per second squared, we simply write Newton. There is no shortened form of the SI unit of momentum. So there's no spiffy name that we call this or anything like that. It's simply a kilogram meter per second. So anytime you see kilogram meter per second, you can automatically think that's a momentum.